This is Wendell Omubualan, and today let's delve into graph linear inequalities and two variables. So first is graph the equation, treat the inequality and plot the line. So number 2 is determine the line type. So solid line for greater than or equal to or less than or greater than, and a dash line for greater than or less than. And number 3, test a point. So substitute a point not on the line into inequality. If true, shade that side, and if false, shade the opposite. And number 4 is that shade the region. So shade the area that represent the solution set. For example, for y is greater than or equal to 2x plus 3. So first is plot the y equals 2x plus 3 with a solid line. Test point 0, 0 if true, shade below the line. Example, for 3x is negative 4y less than 12. Plot the 3x is negative 4y is less than 12 with a dash line. So test point 0, 0 if false, shade the opposite side. In summary, convert the inequality to an equation. Plot the line, test a point, and shade the correct region to graph inequalities with two variables.
Hi, my name is Lovely. Now let's talk about first, the interval notation is a way to represent a set of real numbers using inequalities. An interval notation is a set of numbers is enclosed in parentheses or brackets and separated by a comma. We have three types of interval. First is open interval, second one is closed interval, and the third one is half open or half closed interval. Now let's talk about the property of inequalities. Inequalities are statements that compare the relative size or order of inequalities. Here are some key properties of inequalities. First, we have additional and subtraction. Additional or subtraction of any real number on both sides of an inequality will not change the sense of inequality. When we say inequality, it doesn't change. And the next one is multiplication property of inequality. The sense of inequality is changed only when multiplying or dividing both sides of the inequality by a negative real number. There is possibility the sense of
Linear programming is a mathematical technique used to optimize decision-making by maximizing or minimizing the linear objective function subject to linear constraint. Linear programming has a subtopic of decision variable, constraint, objective function, and feasible region. Decision variable represent the unknown quantities to be determined, while constraint limits their values within a feasible region. The function define the optimization goal, which can be maximized or minimized based on the concept of the problem. For example, let's say the linear programming problem with a decision variable of x and y. So the objective function is to maximize profit given by z equals to 3x plus 2y. So the constraint includes x plus 2y less than 14 and 3x minus y greater than 0 and x minus y less than 2. These constraints define the feasible region, which is the intersection of all constraints and represent the set of solutions to satisfy the constraint. So for linear programming problem, we follow these steps. First, define the decision variable. Formulate the objective function. Specify the constraint, find the feasible region, optimize the feasible region within the objective function, and lastly, interpret the result. So how will we know if the problem is maximized or minimized? Whether the problem is minimization or maximization depends on the keywords of the problem statement and analyzing the coefficient of the variables in the objective function. So look for a keywords. So some keywords in minimization problem are includes minimize, reduce, mean, or cost, while in maximization problem it includes maximize, increase, max, and per.
The proposition is a declarative sentence that is either true or false. Now moving forward to the types of proposition. Starting off with simple proposition. It is a proposition that conveys one thought with no connecting words. Now moving forward to compound proposition. It contains two or more propositions that are put together using connecting words. So there are 5 types of compound proposition. Number 1 is negation. It is a statement that is false whenever the given statement is true, and true whenever the given statement is false. Next is conjunction. It is two simple propositions connected using the word and. Next is disjunction. It is two simple propositions connected using the word or. Next is conditional. It is two simple propositions connected using the word if-then. It is denoted by P, if-then, Q. And lastly, by conditional. It is a combination of two conditional statements, where it is defined to be true whenever both parts have the same truth value. It is also denoted by P, if, and only if, Q. Now lastly, the universal proposition. It is a statement that asserts something about all numbers of a particular set or category. It involves quantifiers such as for all.
Now let's proceed to exercise
existential proposition. In math, it is a statement that asserts the existence of at least one element in a set that satisfies a given property. So we have the existential quantifier. In mathematical logic, the existential quantifier is symbolized by this. So it looks like a mirrored letter E, right? Which means there exists. So for example, this statement. So how can we read this statement? So basically, this reads as there exists an element x in the set S such that the property Px is true. So now, moving forward to the other type of proposition, we have here the conditional proposition. It is a statement that can be written in the form if P then Q, where P and Q are statements and it's often symbolized as letter P and then arrow towards a letter Q. So for example, we have here the letter P. So our letter P here is it is raining while our Q is the ground is wet. So basically, the conditional proposition would be if it is raining, then the ground is wet. Now, we have here the types of conditional statement, namely the implication, inverse, converse, and contrapositive. So now, moving forward to the last type of proposition, we have here the biconditional proposition. It is a statement that is a type of logical statement that asserts the equivalence of two propositions. It is true if and only if both propositions are either true or false together.
First subtopic is modus ponens. It is a Latin word of method of affirming. If P is true and Q is true, P is true, therefore Q must be true. Next is modus tollens, hypothetical preposition according to which if the consequent is denied, the antecedent is denied. If P is true, then Q is true. P is not true, therefore Q must not be true. Hypothetical syllogism is a deductive syllogism with a conditional statement of one or both of its premises. If P then Q, and if Q then R, therefore if P then R. Destructive syllogism is a valid argument form in propositional calculus. Either P is true or Q is true. P is not true, therefore Q must be true. Structure dilemma is a valid rule of inference in propositional logic. Either P implies Q or R implies S, either P or R, therefore Q implies S.
Symbolic logic is a principle that allows you to substitute one logical expression with another equivalent expression within a logical formula. Absorption laws are rules in Boolean algebra that allows you to simplify logical expressions by replacing more complex part with simpler equivalents. The associative laws state that the between of variables in addition or multiplication does not affect the result. A commutative law states that when we add or multiply two numbers, then the result volume is the same, even if we change the position of the two numbers. Contradiction is a logical inconsistency where a statement and its negation both hold true simultaneously. This leads to contradictions easily and can disrupt the validity of logical arguments. De Morgan's law is fundamental rules in logic that relate the operations of conjunction and disconjunction with negation.
Hi everyone, now let's talk about conditional, biconditional, and related statements. Let's define first or get to know what is a statement. So statements are declarative sentences. It is a sentence where I declare something. For example, he is handsome. I declare that he is handsome. Therefore, it is a declarative statement. How about if I say, is he handsome? It is not a declarative sentence. Therefore, it is not a statement because it is an interrogative sentence. First, conditional statements. These are if-then statements. For example, if it rains, then the ground gets wet. Here, if P, then Q. Next is biconditional statements. These are true in both directions. For instance, you pass the test if only if you study. This means P if and only if Q. Now, related statements. The converse flips the conditional if Q, then P. For example, if the ground is wet, then it's wet. The inverse negates both parts. If not P, then not Q. So if it doesn't rain, then the ground is not wet. finally, the contrapositive. Contrapositive flips and negates. If not Q, then not P. Like, for example, if the ground isn't wet, then it did not rain.